What's going on, everybody? Welcome to my channel, and in this video I'm going to talk to you guys about another interesting program, and this is going to be of also an application program. Alright, in this program we are going to find the factorial of a variable, factorial of a number. Alright, with a little bit of ifs and buts conditions to make sure that the value is perfect. Alright, so let's get started. So we're going to calculate the factorial of a positive number, positive integer. Okay, and I mean by positive integer because factorials only exist for positive integers. All right, as per the mathematical concept, so to speak. Most of you might know what a factorial is, but just to give you guys a little bit of a refresher, a factorial is actually a successive product of from successive multiplication of 1, 2, 3 up to a particular number. For instance, if you have like 5, then 5, if your number n is equal to 5, then n factor 5 and the factorial of 5, which is actually written as 5 exclamation mark, is actually 5 times 4 times 3 times 2 times 1, right? Okay, likewise, if you want to say something like 25 factorial, this is actually 25 times 24 times 23 and so on and so forth times 1. You have to go all the way up, all the way to the end of it. Alright, you can write this in reverse order as well, doesn't matter, right? So this is how it is. Factorial by definition is not defined for negative integers, and for 0 factorial the value is kept as 1. That's about it. These are the things you have to keep in mind while making factorial programs. Okay, so first things first, let's ask the user like for what value he or she wants the factorial to be calculated. For that, let's call in n. And for this, we need the int function, and inside that we need the input, and we'll put a prompt, enter the value of n. That will do, right? That will do. Now what we'll do is we'll have to do some little bit of house cleaning stuff using if statements. Now the user might enter some negative values, right? So we have to check if n is less than 0. If n is less than 0, here we already checked if it's integer, so that is taken care of, right? So that is taken care of, so it's fine, then it's fine. All right, now what we can do is if n is less than 0, what's the issue? Then factorial does not exist, right? So we have to say print factorial of a negative integer does not exist, and then if you want to you can quit the program over here. For that, we can use a keyword exit. Now this is another keyword that is available, which helps you to break end the program as it is. And now here's the thing. Now what we'll do, we will call in the else statement over here. Now think about it. When I check n equal to 0, when n is less than 0, we are testing for all negative values, and the moment we put integer over here, we are only considering only integer values. Okay, and there we go. That part is taken care of. And now the else statement, we have to check if n is 0 or 1. Okay, and that you can literally write it as I told. We just say if n is 0 or 1, right? Wonderful, isn't it? This is pretty much like English written as it is, and we can just say fact equals 1, right? We can just say fact equals 1, and that's it. You can just say fact. Okay, we'll remove this line. And this is the factorial. We can just say fact equals 1, else we'll create a value fact equals 1, and then we'll say what we'll say for, and then we'll have to do like multiplication. For we can say for I in range, what we should do is we have to start from 2. We can skip 1. We have to multiply the number by 1 and then 2 up to all the way to the number, right? So we can skip 1 and we say 2, and you have to go till that number plus 1 value, so that number is included, and we go in steps of 1. We'll say fact equals fact times I. This way you keep multiplying it again and again, and you have the factorial value at the bottom, and we can say print, and we can say the value of n factorial is fact. And there we go, and that's it. Our program is officially over, right? Now let's run this little piece of code and see what we're getting. We'll get a prompt like this. Now let's enter 5, and it says the value of 5 factorial is 120. Cool. And there you go, it's done. Now if what you can do is let's run this code for different cases. Now let us enter the value of 0, and what we get, the value of 0 factorial is 1. Cool. And now let's try some other value of 1. We say the value of 1 factorial is 1. Perfect. And what about 2? And it's working perfectly. Wonderful. Now let's actually be like a devil's advocate and try to see if our code is working even in the case when the inputs are wrong. Alright, now what we'll do is let's run this code, and let's enter some values like -25 and press enter. It says factorial of a negative integer does not exist. Alright, okay, that's it. Factorial of an integer does not exist, and we're getting an error which says fact is not defined, because we are printing this statement only when this is correct. So we have to put this print statement within this else loop. Otherwise this program should exit like this, right? That's how it is. That's how we're defining it. So if I were to enter like in the same value -25 over here, it says factorial of a negative integer does not exist, and the program shuts down. Cool. Now this part is working fine, and now what else we can do is that we can actually make this a little more fancy. How? Let's actually start calculating the factorial of each and every number, right? So for that, let me create a value n1, okay, and then let's call in a loop for j in for n in range. Let's say for n in range, what we call it 0 till n plus 1 till 1, some n in steps of 1. We'll put that, and what we'll do is we will cut this. Okay, we'll cut this, and I'm talking we'll press it, we'll put it here, n1, okay, and we'll tap this one more level, n1 plus 1, okay. There we go. And this program remains pretty much the same. The only thing I'm doing here is, if the user were to give some wrong value of n1, let's say, and if it's a negative value of n1, it's just going to say factorial of negative integers do not exist, and then it's going to shut down. That's it. Otherwise, if the user were to enter a valid integer like 0, 1, 2, 3, and so on and so forth, it's going to calculate. This for loop is going to run for each and every value of n, and it's going to calculate and print the value of fact, right? And then it's going to start with 0, and then it'll go for 1, 2, 3, and now what we're going to get here is the value of 0 factorial is this, value of 1 factorial is this, value of 2 factorial is this, like that, right? Now let's actually run this code and see what we get. If I were to enter something like 6, okay, 5, not 6, let it be, we get the value of 0 factorial is 1, the value of 1 factorial is 1, the value of 2 factorial is 2, the value of 3 factorial is 6, the value of 4 factorial is 24, the value of 5 factorial is 120, and the value of 6 factorial is 720. Neat. Now with this little piece of code, now we are able to calculate the factorial of n numbers, n successive natural numbers. Neat. This way we not only did a small factorial program, we also used the exit statement, and we also used a nested for loop. We have a for loop, and inside this for loop we are using other for loops. This way we have an idea of what a nested for loop is too, right? And with that said, that's all I have for you all in this video. In the next video, we'll make this into a function. So stay tuned for that.